The next question we're going to look at is this one. So they are first asking you to sketch the circuit. The resistors are 1 kilo ohm and 5 kilo ohms, and the EMF of the battery is 4.5 with negligible internal resistance. So you have 1 kilo ohm, you have 5 kilo ohms, and the EMF is 1.5 volts. The internal resistance is negligible. That means EMF will be equals to terminal potential difference. Earlier we saw an equation relating EMF to terminal potential difference and lost volts, right? So the lost volts is the voltage drop due to the internal resistance. So when this is 0, terminal potential difference will be equal to the EMF, so that will be supplied to the rest of the components. So sketch the circuit and calculate the PD across each resistor. So we have a potential divider setup. We are going to apply this equation. So we're basically going to apply this equation where it says that the potential drop across the resistors will be in the ratio of their resistances. V1, V2 would be in the ratio of R1, R2. So if we apply that here, this 4.5 volts will be in the ratio of 1:5, will be divided in the ratio of 1:5. That means if you say this is V1 and this is V2, V1 over V2 is equal to 1/5. At the same time, we know V1 plus V2 is equal to 4.5. The total voltage drop will be equal to the terminal potential difference, which is equal to EMF here. So if you do that, so V1, if you want to find V1, then V1 would be equal to, I'm applying this equation. So the particular output voltage I'm trying to find will be that particular resistance over total resistance times the total terminal potential difference. If I apply that here, so the total resistance is 1 plus 5, 6. The V1 is for the 1 kilo ohm, so 1 times the total potential difference is 4.5. So that is equal to 0.75 volts. So the total is 4.5. If this is 0.75, then the remaining would be 4.5 minus 0.75 that would be 3.75 volts. Then they are saying that a second 5 kilo ohm resistor is connected in parallel with the existing 5 kilo ohm resistor. So now what we are going to do is we are going to connect another 5 kilo ohm resistor here in parallel. Now nothing would change except this would become, the equivalent case would become, here we will have the 1 kilo ohm, but you have two 5 kilo ohm resistors connected in parallel. So if you want to apply that 1 over R is equal to 1 over R1 plus 1 over R2, you can apply it and find the resultant resistance for these two. Or else when two equal resistors are connected in parallel, the resultant will be one of them divided by 2. So 5 divided by 2 is 2.5 kilo ohms. So this is 4.5 watts. Now just the same things, but you have different numbers here. So we have to, the new V1 would be, now 1 plus 2.5 is 3.5 times 1 times 4.5 watts. So that's approximately equal to 1.3 volts. Then V2 would be equal to 3.2 volts. Okay, so this is the fundamental idea of a potential divider.